give you kind of like a basin analysis overview of the Concho River system. And so he has his degrees from UTPB, which is University of Texas Permian Basin. It's over in Midland to the north. Been working for what, 20-some years in the field.
More than that, over 30.
Over 30 years experience. So if y'all have any questions about some of the stuff we've seen in the field or the applications of it, anything like that, feel free to ask me. I'll get out of the way.
And I may have an answer and I may not. I am with the Upper Colorado River Authority. When I thought James asked me if I'd come talk to you, what I thought I would talk about is our watershed protection plan that we've done. And it's not something that you do once and then forget about. It's something that's ongoing. And our watershed here, what we did it on was the Concho River watershed, which is a tributary of the Colorado River. The Upper Colorado, kind of by agreement with the Lower Colorado River Authority, both these agencies were created in 1935 by the state legislature. They set aside, what was it, $3 million for each agency to begin with, to improve water systems, to loan money to cities, to build dams, to do whatever to improve the water availability in Texas. In San Angelo, for whatever reason, our board of directors didn't get very excited back then. They've done a few things. We built O.C. Fisher Dam out here. We were part of that. And we've loaned money to some cities, small towns around for infrastructure needs and those sorts of things. And then the LCRA, which is in Austin, they have about 2,000 employees. So it's a little less than that now. But they had a very active board of directors. And they built what's called the Highland Lakes, Buchanan Dam, Inks Lake, LBJ Lake, all sorts of hydroelectric dams through there. And from that, they branched out to now they own all sorts of energy. And they've got 2,000 employees. And in San Angelo, we have 4. No zeros after, just 4 employees. But we like to say that we can do about as much as they can with 2,000 people, we can do with 4 people. And surprisingly, that's not all that inaccurate because they are a big bureaucracy now and they operate like a bureaucracy, whereas we just see it and talk about it amongst each other and get it done. But we still have to deal with the bigger bureaucracy, so sometimes it's not all that easy. But anyway, the yellow watershed there is the Concho River watershed. That's the outline of it. It's 4.2 million acres. And the outlet there, or the confluence with the Colorado, is now at Lake Ivy, which is down there. I don't know if y'all discussed it at all.
Hey, Jake.
There's a closer view of it with the streams and lakes overlaid on it. This is Lake Ivy, and right now, this lake is dry. These two get some water, because I think y'all went out to the South Concho.
We did. We went to Spring Creek and Burton, and we went down to Crystal.
To the head of the river ranch, where the springs are?
Oh, no, we didn't make it that far. We went to the,
Oh, that's too bad. That would have been.
I understand it's beautiful. At Burton, we were at the low water crossing
Yeah.
town.
Well, just upstream from, in Christoval, where y'all were, is the head of the river ranch, and that's, I think I've got a picture on this slide where the water, the springs come out, and what they water is the Edwards Trinity Plateau Aquifer, which is about this shape in Texas. It's where all of San Antonio, all the water down there flows through that aquifer and comes down there. And the South Concho Springs, the Dove Creek and Spring Creek springs dewater the north side of that aquifer. But anyway, that was the area we're dealing with. This is just an elevation model map. It shows that we've got about 1,500 feet in elevation from the highest point in the watershed over here to the lowest point at the outfall in Ivy.
And he actually provided it in metric for you.
That's right. 450 meters, I could say. There's a picture of Anson Springs. That's the South Concho River, upstream of Christoval, where y'all were. And you can see there's enough head on the water that it bubbles up higher than the water level there. It's really, it looks like you're in Hawaii there. It's really unusual to be out there, and then you walk a few hundred yards away from it and you're back in the desert. It's just a little oasis. And supplies a lot of well, it's the most pristine water we have in this area anymore. And it's the only stream that really runs significantly full time now. And it's only because it's its elevation is lower than Spring Creek and Dove Creek. That's why it dewaters the aquifer first and is able to run when the other two are just barely full. And that's because of the elevation difference. It's about, I can't remember whether it's 100 or 200 feet lower than Spring and Dove Creek Springs. One of the things we've dealt with in San Angelo a long time is urban runoff. This is a picture when the water has been released, when they were dredging back in, I think, in the 80s, was taken, and you can see all the stuff in there. They dredged it back then with mechanical means. They got in there after they dried it out with dozers and such and cleaned it out. But we threw this picture in there just to show what gets in your urban rivers. This is a picture, some of the things we've done in the watershed. We've collected data all over the watershed, the entire 4.2 million acres. We have a network of sample sites. We also work with in Texas, there's a Clean Rivers program, and that's a state-funded, well, it's not state-funded, but it's state-mandated to measure the water quality throughout all the rivers in Texas. And I've got a map in a minute to show you the areas or the actual sample sites where we collect data. But what we collect is water quality, and then of course we do hydrologic work and we do monitoring, and we've done some research with this project and others. There's a side of the areas of the rivers where we sample. This is the main Concho River. San Angelo's right here. North Concho River, Middle Concho, South Concho, Spring and Dove Creeks. So those are the areas that we go out to quarterly and take samples, measure flows, and notate anything, if anything unusual is going on. And we've done habitat assessments in many of the areas also. In some areas, like I say, we've got 4 people in our agency. We're not a wealthy agency. We have to get by with what we can do. This was one stream bed we wanted continuous monitoring on, so what we wound up doing, because we didn't have a USGS gauge, we put a pressure transducer down inside a piece of pipe on a T-post, and we can measure the cross-section of the stream bed there, and we can get pretty accurate flows of what goes by there during stormwater. We did this in just on the fly because we wanted the data there. We can get reasonably accurate data pretty cheap that way. Here's some more equipment. Dr. Ward told me y'all were looking at field stuff, so I've got a picture of a lot of field equipment that we're using. This is an ISCO sampler. It's got a bubbler on it, and it measures the pressure that it takes to push out a bubble of air. And when it detects that water has risen to whatever level you program into the computer inside this, there's a computer, well, that's it right there. There's also a top that goes over and covers the whole thing, so you can leave it out in the weather. But this computer, then, you can tell it when you want it to start sampling and how often you want it to sample. And it'll automatically pump water in and sample water. It's got 24 sample bottles ringing the bottom of it. So we can collect our samples that way, and then we can do a time-weighted sample, or a flow-weighted sample, and send it in, or we can tell it to do whatever we want it to do, really, however we want to program it. And we're provided with a hydrograph and then samples throughout that hydrograph. We know where the samples are taken. So that gives us very useful data, especially when we're dealing with things like stormwater in the city. These are some ag issues that we had in our watershed. This is in the main Concho. San Angelo's down here. Lake Ivy's back over here. Miles is up here. And this is the Concho River down through here. On this site, we've got several different areas on this site that have concentrating animal feeding operations, and Willow Creek suffers from it. And so we selected that site as a special study, and we would collect stormwater. We get a lot of complaints. We used to this area up here has gone out of business, but used to the landowners just downstream a bit would call us pretty much every rain because the guy's structure was over, his wastewater structure was overflowing, or he was not applying water like he's supposed to the land application unit, so our land management unit around there. And the water quality in Willow Creek when it's running is really, really poor. It contributes a lot of nitrates and bacteria downstream, and that's one of the things that this section of the river is listed for by the EPA is being real high in nutrients, nitrates, phosphorus, those sorts of things.
So the feed yard is still in operation?
No, the one up, the dairy up there is no longer operating. But San Angelo, the one on the highway here, San Angelo Feed Yard, and there's one right across the road from it. And there's a little one somewhere else up there, I don't have it marked. And then there's another one going in just downstream a little bit. So the reason they come out here is because they've got a good supply of water out there. And just as an aside, in 1990 there were 200 irrigation wells on the flats out there east of town, and within 10 years there were over 1,000 wells. So the water's not as reliable as it used to be because everybody's pumping it. It's got a little Pan-Kickapoo aquifer.
Which we looked at yesterday, the La Pan flat that we were doing all the work on the wells on, that's impacted by what he's saying there.
This area is north of town. It's the community of Grape Creek. Have y'all been through or mentioned that at all?
No, we're going up to ASU Ranch tomorrow.
Okay, well, it's,
So yeah, we'll be up at OC Fishing
ASU
tomorrow.
Ranch is right here. If I'm looking at that right.
Yes, sir. Part of it comes all the way down to water.
Yeah. Yeah, this is part of their roadways right here. Goes all, covers that area right there. But one of the things we did for the watershed protection plan is there has been a known problem with bacteria in that yellow circle. There's several thousand people that live out at Grape Creek, and none of them are served by a sewer system. It's all individual septic tanks on each house. And we sampled like 30 different water wells in the area. In the past, it was supposed to be a lot of bacterial problems, and we didn't get any hits for bacteria. And we aren't sure why, but we think it's related to the drought, that it just wasn't leaching into the water table. It's a fairly shallow water table, but during this, it was in the middle of a severe drought that we did our sampling. And somehow we think that's what confounded our results. But it made everybody happy there because they don't have to spend money, tax money to get a sewer system. But that's one of the things we're going to go back later and resample that because we're pretty certain there's some problems out there. And there's probably some in Cristobal because you've got a pretty dense population out there of the same system, just all septic tanks, no sewer system. This is that's the North Concho River watershed outline there. It's about a little less than 1 million acres in size, so it's about 1/4 of the entire Concho watershed. And those are all locations where I had permission to go sample water wells. One of the things we were doing, we had a big brush control program in this area, and we sampled water wells for probably 8.5 to 9 years to see the effects that the brush control would have on it. And that was the grid of wells that I was sampling. We incorporated all that information into our watershed protection plan also. We had some research associated with it. Paired watershed sites was funded by the Texas State Soil and Water Conservation Board as part of that pilot project for brush control. These are some of the towers we had. We started out with Bowen ratio systems, and we were not getting good results, and we went to the 80 covariance method of determining what the evapotranspiration was. We had here are 2 sites, paired watersheds, each of them 200 acres, monocultures of mesquite, and we measured evapotranspiration right after we got the sites, and then we treated this site over here by aerial application with Reclaim Remedy, got about a 70% kill on the mesquite, actual root kill that they didn't come back, and then we measured the evapotranspiration after we killed that. And we had some very good results on that. Actually, what happened, are y'all familiar with the SWAT model? Some of y'all have heard of it? Because I know it's international, a lot of people use
It's
the SWAT model.
linked in the, doesn't it link directly to mod flow?
I think there's a way to link it.
mod flow. It was developed by USDA, if I remember correctly.
A&M's had a lot,
Yeah.
promotes it a lot, and uses it a
Right, I
lot.
think like
But
Temple or somebody like that, but,
USDA
yes, it is
is
internationally
yeah.
used.
It's soil water assessment tool, and it's part of the feasibility study of the brush control program. The SWAT model was used to predict how much water would be conserved if we filled the brush. I think I've got that on here a little better later, I'll talk about it. There's a picture of this site over here, that's us spraying the mesquites on the site we treated, and that's right, taken from the same angle a few days afterwards with mesquite dying. Here's pictures of the towers, and we had them down, installing the equipment, getting it ready to go back up. This is when we switched to the eddy covariance method and changed out our instrumentation to do that. We found it's a much better way to go. If you're measuring evapotranspiration in fields, croplands, mowing ratio works well, but in pasture areas such as this, rangeland, the eddy covariance was a much better tool to use.
Do we still have the equipment and stuff?
It's still out there, I don't know what shape it's in, except for, hang on, I'll show you one picture in a minute. That's Chuck Brown, a guy I work with, up on top. We had to go up every so often and clean it off to maintain the equipment and download the data. That's obviously the site that wasn't treated. We also did grass transects out there and between the treated site and the untreated site. Measured that on a regular basis. This is a picture, we had a fire go through. They had an arsonist. They traced the fire right back to a box of matches and the cigarette laying on the ground. And it burned through our treated site. That's what it was like the next day when we went out.
Oh, no. Research is
There's our
over.
site.
Oh.
And the fire melted batteries, of course.
Oh.
Anyway, we were all pretty shook up with it when it happened, but actually it gave us a good opportunity to see what would happen after a fire, see how fast these mosquitoes would come back, study that. So we've got our instrumentation back up. There's an outline of where the burn area went within our 200-acre.
It almost took it all out.
So that's where the tower location. And here's the tower. It's funny how it went right along the line of that's our square right there. That's our 200-acre plot. So it burned almost the entire plot, and over here left it almost untouched. So we got a good paired watershed view of what happens after a fire too. Okay.
Did that next one on the top.
Okay, I don't want to talk about that. Next, we also have paired watersheds at two juniper sites. We found two little headers up in the limestone hills up in there. Pretty close to the same size and about the same slopes, as close as we could get to two watersheds to be, as similar as we could find. We installed cans under there. We blocked off all the flow so we could catch all runoff coming over those two sites. We installed two cans and instrumentation to measure flows. We use those ISCO samplers with the bubblers to measure the flows there too. What we were wanting to do there was see what the difference in flow would be and runoff would be by leaving one side untreated and treating the other side. You can see up here we installed a flume and ran it off of this same machine or one of these data recorders. The other one was working off of the cans. But what we found was we didn't have these installed to start with, but we were missing low flow events where we'd have just small runoff amounts. So we installed those, and then we were getting all the water that came off those watersheds. Plus we had a tipping rain bucket here to get our rainfall, and obviously our solar panel with charging batteries. One of the things that we've always done in our watershed protection plan, and anything, when EPA gives you money to do something, one of the most important parts of it is outreach and education. And Christy Euger is our outreach and education PhD, sitting right back there in the red dress, and does a wonderful job. This is a picture of our board of directors. We took them out on one of our projects that we've done. We had public meetings to get input from interested people